Hello guys and welcome to our YouTube channel Apexsalesforcetutorials.com. Please support us by clicking the bell icon and subscribe button, and also share the YouTube channel with your fellow mates and colleagues who are interested in Salesforce technology and going more forward within this. In today's video, we'll be discussing about Salesforce LWC interview questions, which are for freshers. These questions are basically based on fundamental concepts of Salesforce, and we'll provide detailed explanations for each question to help you understand them better. So let's get started with it. Our very first question is, what are the key features of Lightning Web Components or LWC? The answer is Lightning Web Components offer several key features that make them powerful for building modern web applications. First is enhanced performance. LWC leverages modern web standards and techniques, resulting in faster loading times and improved user experience by minimizing the use of JavaScript frameworks and optimizing rendering. LWC ensures efficient performance even with the complex applications. Second is reusability. LWC provides a component-based architecture, allowing developers to create reusable components that can easily integrate into different parts of an application. This modular approach enhances code and maintainability and scalability. Third is secure and robust. LWC follows Salesforce security model and best practices, mitigating common security and vulnerabilities such as cross-site scripting or XSS and cross-site request forgery, or known as CSRF. With built-in security features, developers can build robust and secure applications. Fourth is seamless integration. LWC seamlessly integrates with other Salesforce technologies like Apex, Aura, components, and third-party libraries. Developers can leverage existing Salesforce data and services, reducing the development time and effort. Our second question is, how are Lightning Web Components different from Aura components? This is a very important question usually asked in the interview questions. The answer is Lightning Web Components, LWC, and Aura components are both frameworks for building components on the Salesforce platform, but they have some key differences, which are: first is programming model. LWC follows a modern programming model based on web standards like ECMAScript 6 and HTML5, while Aura components use an older proprietary programming model. LWC's use of standard web technologies makes it more accessible to a broader audience of developers. Second is performance. LWC offers better performance compared to Aura components due to its optimized rendering and a smaller footprint. LWC components load faster and provide a smoother user experience, especially in large-scale applications. Third is standardization. LWC aligns more closely with industry standards and best practices, making it easier for developers to transition from other web development frameworks. With a more standardized approach, LWC promotes code consistency and interoperability. Our third question is, how can you dynamically create components in Lightning Web Components? And so for this is, in Lightning Web Components, you can dynamically create components using JavaScript by importing the createElement method from the DOM module. This method allows you to instantiate a component dynamically, specifying its tag name and any additional attributes. Once created, you can append the dynamic component to the DOM as needed. This approach enables developers to create components on the fly based on the user interaction or runtime conditions, providing greater flexibility and customization in their applications. You can take a look at this through the code provided. Our fourth question is, what is the role of decorators in Lightning Web Components? The answer is that decorators in Lightning Web Components are used to define metadata for the component class, such as properties, methods, or lifecycle hooks. They provide a declarative way to annotate and configure component behavior, making the code more readable and maintainable. Our first type is API decorator. The API decorator is used to expose a property or method to parent components, allowing them to communicate with the child component. This enables parent-child components and data sharing in a controlled manner. Second is wire decorator. The wire decorator is used to wire a property or function to a Lightning data service or Apex method, enabling reactive data fetching and synchronization. This simplifies data accesses and management in Lightning components. Third one is track decorator. The track decorator in LWC is used to mark a property as reactive enabling automatic UI updates when the property's value changes. This ensures that the changes to tracked properties are reflected in the components template without requiring manual updates. Decorators play a crucial role in defining component behavior and facilitating communication between components in Lightning Web Components. Our fifth question is how can we handle events in Lightning Web Components? This is also a very important and crucial question usually asked in interviews. Events in Lightning Web Components are handled using standard DOM event handling methods like add event listener, or by using the wire decorator to wire event handlers to specific events in the component template. Here's how you can use handle events using both approaches. First one is by using add event listener. You can add event listeners to DOM elements within the component template using the add event listener method. For example, to handle a click event on a button element, you can check for the code which is given. Our second type is using the wire decorator. You can also use the wire decorators to wire event handlers directly to specify events in the component template. For example, you can check for with the code given as to handle a click event on a button element. You can go through the code. Now, both the approaches allow developers to handle events in Lightning Web Components effectively depending on the specific requirements of the application. Our next question is what is the difference between track and API decorators in Lightning Web Components? The track and API decorators are both used to define properties in Lightning Web Components, but they serve in different purposes. First one, the track decorator. The track decorator is used to track changes to a property within a component and force a re-render when the property changes. This ensures that any changes to tracked properties are reflected in the component's template. Second is API decorator. The API decorator is used to expose a property or method to parent the component, allowing them to communicate with the child component. This enables parent-child communication and data sharing in a controlled manner. In summary, track is used for reactive property updates within the component, while API is used for communication between different components. Our seventh question is how can you invoke an Apex method from the Lightning Web Components? You can invoke an Apex method from Lightning Web Components by using the wire decorator to call the method imperatively, or by importing the method from an Apex class and calling it directly. Sometimes this is also used just simply called the imperative call. Here are the two approaches: imperative Apex call with the wire method. Using the wire decorator to call the Apex method imperatively and handle the responses asynchronously. This approach is suitable for one-time data fetching or fetching data based on user interactions. You can go by the code as provided. Our second part is direct Apex method invocation. Import the Apex method from an Apex class and call it directly from the Lightning Web Components. This approach is suitable for invoking methods based on the specific component lifecycle events or user actions or interactions. Both approaches allow developers to invoke Apex methods from Lightning Web Components effectively depending on the specific requirements of the application. Our eighth question is what is the role of rendered callback lifecycle hook in Lightning Web Components? We'll get with one of the more important questions like what are the lifecycle hooks in Lightning Web Components in the coming videos. For now, we are going with this one. The rendered callback lifecycle hook in Lightning Web Components is called after the component's template has been rendered and can be used to perform tasks that require access to the component's rendered DOM, such as setting up event listeners or manipulating the DOM. Here's how you can use the rendered callback method by going through the code snippet provided. The lifecycle hook is useful for scenarios when you need to interact with the component's DOM after it has been rendered, ensuring that any DOM manipulation or setup logic occurs at the appropriate stage of the component lifecycle. Our eighth question is how do you handle errors in Lightning Web Components? Error in Lightning Web Components can be handled using standard JavaScript error handling techniques like try catch blocks, or by using the onError event handler to catch unhandled errors. Here's how you can handle errors using both approaches. First is using try catch block. Grab the code that may throw an error inside the try catch block and handle the error gracefully. This approach allows you to catch and handle errors within the component's JavaScript code For example, the code is given. We can check that. Second approach is using on error event handler. Use the on error event handler to catch unhandled errors at the global level and log or to display them appropriately. This approach allows you to capture errors that occurred outside the component's JavaScript code, such as in event handlers or asynchronous callbacks. Both the approaches allow developers to handle errors effectively in Lightning Web Components, ensuring a robust and reliable user experience. Our 10th and last question is, what are the best practices for optimizing performance in Lightning Web Components? Optimizing performance in Lightning Web Components requires a combination of best practices and techniques aimed at minimizing resource consumption and improving rendering efficiency. Here are some key best practices. First is minimize tracked properties. Limit the use of tracked properties, or we can say @track to only those that require reactive updates. Excessive use or tracked properties can impact the performance, so prioritize tracking only critical properties. Second is lazy load resources. Load resources such as JavaScript libraries, images, and CSS files lazily to reduce the initial page load time. Use techniques like dynamic imports or asynchronous loading to defer resource loading until they are needed. Third is memoization. Implement memoization techniques to cache expensive computations or function results, reducing redundant calculations and improving performance. Memoization can be achieved using custom caching mechanisms or libraries like Lodash. Our next approach is optimize HTML and CSS. Minimize the size of HTML and CSS files by removing the unnecessary markup and styles and optimizing selectors and rules. Use tools like CSS minifiers and free shaking to reduce the file size and improve rendering speed. By following these best practices, developers can ensure that Lightning Web Components are optimized for performance, delivering a fast and responsive user experience. This concludes our discussion on Salesforce LWC Freshers interview questions. We hope you found the video helpful in understanding the fundamental concepts of Salesforce and preparing for your interviews. If you have any questions on topics you would like us to cover in future videos, please let us know in the comments below. Don't forget to like, share, and subscribe to our channel for more informative content. Thank you for watching, and we'll see you in the next video.